Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in this particular video, we'll be discussing a test of Pure Maths 1, P1, A-level Maths. And the test is on two particular topics, that is coordinate geometry, the straight line portion. And the second part is on circular measure. So these are the two basic topics on which this test is made. So now let's look at the first question. This first question is the diagram shows an arc BC of a circle center A. So that is BC, that's the arc of a circle center A, radius 5. That means AC is 5, AB is 5. The length of the arc is 4 centimeter. So this arc BC is 4 centimeter. The point D is such that BD, that is BD, is perpendicular to BA. So this is a 90-degree angle. DC is parallel to BA. So this is DC, that is over here, that is parallel to BA. So of course, since it's a right angle triangle, it has to be parallel like this. And then they are asking us, find the angle BAC in radians. So first thing first, whenever we do a circular measure question, two things needs to be considered. The angle has to be in radians. And naturally, the calculator has to be in the radian mode because when you use sine, cosine, tangent, so when the angle is in radians, that is when it will give you the correct result. So the calculator has to be in the radian mode and the angle has to be in radians. So now I have labeled this angle as theta and I apply the simple formula arc length CB is equals to r theta. So arc length CB is equals to r theta. So r in this case is 5, theta is unknown and this arc length is 4. So theta comes out to be 0.8 radians. That is the first basic thing. Then it's asking us the area of the shaded region BDC. So now let me grab some sticky notes and let me just place it over here so that you can just focus on that particular question and then you can look at the solution later on. So now in order to find use cosine, sine, tangent, you need a right angle triangle. So what I have done is that I have marked this point Q such that CQ is parallel to DB. And now I have a right angle triangle. I have this angle. I have the hypotenuse. Opposite of 90 is hypotenuse. I can use sine, I can find CQ. I can use cosine, I can find AQ. So let's focus on this triangle in order to find CQ. CQ is the one in blue color. So let me just highlight the blue color, that is CQ. And then we find what is CQ using the calculator. So CQ is this much. Similarly, AQ is colored in green. So let me grab a green color. Cos theta is AQ over 5. Therefore, AQ is this much. So now once this is done, what else do we need? We can find the area of this whole sector. We can find the area of this trapezium and then do the subtraction. Trapezium is big. It includes the sector. We can find the area of the shaded region. So now in order to find this length, we have AQ. Subtracted from 5, we will find QB. So first thing first, that is over here. QB is the radius minus AQ. That is this much. CD is the same thing as QB. DB is the same thing as CQ. CD is the same thing as QB and DB is the same thing as CQ. So CQ was already known. So now this will be the height for the trapezium. These two are parallel sides. That is how you find the area of trapezium. Half CD plus AB multiplied with height. Don't forget the half. This comes out to be 11.69 working in 4SF. And over here, the area of the sector, that is half r squared theta. That is exact. The difference between the two, that is this answer, correct to 3 significant figures. That is the final answer over here. The next question, question number 2. So now in question number 2, it says there are these 2 points and let me grab a highlighter. There are the 2 points A and B and they have coordinates such and such respectively. The line BC is perpendicular to AB, intersects the x-axis at C. Find the equation of BC. That is the perpendicular. It's not a perpendicular bisector, it's just a perpendicular. And the x coordinate of C, that is the first part, and find the distance AC. This time they are asking for the answer in 3dp. So now first thing first, we have A, we have B, we find the gradient of AB. Therefore, gradient of AB is 3/4. Gradient of BC is negative reciprocal. B is 3/4. So now these are the values that you have. We have BC, that gradient we have the coordinates of B. Hence, we find the equation of BC. So equation of BC is this thing. Now line BC intersects the x-axis at C. Therefore, y coordinate is 0. Therefore, the coordinates of C are 6, 0. That is the first thing. The equation of BC, that's done. The orange one and the pink one, that's the coordinate of C. Find the distance AC. So we have C over here, 6, 0. We already have A over here. We apply the distance formula. If they were asking answer in the exact form, I would have left this thing as it is. So this would have been the exact form. But since they have specifically talked about decimal places, so therefore I have rounded it off. I think that is the basic thing, very simple. Question number 3. Now let me focus over here. That is this thing, BD. That is this line over here. And if I draw this thing, that is AMC, that is going like this. And these two are perpendicular to one another. Why? Because it's a property of rhombus. So we have the property of rhombus. That means the diagonals are perpendicular to one another. Not only it's true for rhombus, it's also true for a square. That is one property that's used. The second property that will be used is that since it's a parallelogram, opposite sides are parallel as well as equal in length, and the midpoint of AC should be the same thing as midpoint of BD. So these are two things that will be used in this particular question, besides a lot of other things. So now everything is there that you can see, and let's work it out. So we have B, we have D, we find the midpoint M, that is 4, 6. We have the gradient of BD, that is negative. Also make a habit of looking at the line. So BD is going like this. Therefore, the negative reciprocal would be the gradient of this. This is negative, this is positive. This is negative, this is positive. So now let me write over here, gradient of AMC is positive half. And let me highlight this thing in green color. So that is this thing, and this is the coordinates of M. Hence you find the equation of this line. When the line meets x-axis at A, y coordinate is 0. Therefore, you make the y coordinate 0, you find the coordinates of A. So first we found the coordinate of M, then A, then now the distance thing. Not the distance thing, the midpoint thing. You can do it with distance and gradient also, but that's a waste of time. Rhombus, it's a parallelogram. Midpoint of diagonals is the same. I have written A, I have written C, I have written B, I have written D. Average of x coordinate, average of x coordinate should be the same. So we are working on the x coordinates, and x comes out to be 16. We are working on the y coordinate, and the average is the same. So hence we find the coordinates of C, which is 16, 12. Pretty basic. Question 4, we have solved similar question like this in class. I think that was question number 45 from the topical book. So now over here, there is one thing which is, they are asking us the arc length. This is x, this is x, this is theta, all these things. And they're asking us the arc length as this. In that question, they did not mention it as such. So now over here, for arc length, I need this radius. So first of all, I need to find OA. And OA can be found either using cosine rule, but that will involve a square root. And I don't see any square roots over here. So what I have done is that I have drawn a perpendicular from P to M. Since it's an isosceles triangle, so let me mark it. So now over here, PO is the same thing as PA. It's an isosceles triangle. So when we drop a perpendicular, the base is dissected or bisected equally. So let me focus on this triangle, that is OMP or OPM. If I use cosine of theta is OM divided by X. X is the hypotenuse. So hence we find OM, that is X cos theta. Since M is the midpoint of OA, therefore OM is the same thing as MA, therefore OA is twice of OM. That's twice of OM. Arc length, R theta, R is this thing from here, theta is this thing. All they have done is to put theta in the middle and nothing like that, and nothing special about it. Find the area of the shaded region, area of the same triangle. Now I'll use this thing as the base. This will be the height, that will be the area of triangle. I'll use this as the radius, I'll use this as theta, that will give me the proper formula, the area of sector. The difference is the shaded region. Area of triangle, that is half into base into height, that is the height. I have calculated it separately. So the height is calculated separately. And now over here, this thing which I have calculated separately, PM, that is x sine theta from here. And OA was calculated earlier. So OA was calculated much earlier. That was 2x cos theta. So half base into height, that is this thing. Just double check the working. Half into 2 cancels out. X into x, x square, sine theta, cos theta. Area of sector OA square, radius square. So 2x whole square, cos theta whole square, that is 4, that is x square, that is cos square theta. This theta remains as it is. 4 and 2 cancels out. This is what you get. The difference is this much. I think that there is a lot of space that's given. Question number 5. It says in the diagrams, the points A, B, C have coordinates such and such. Line AD is parallel to BC. Line AD is parallel to BC. That means I can use B, I can use C, I can find the gradient. I can use that gradient over here with A, so I can find the equation of AD. That is what they're asking us. And then I have A, I have C. I can find this gradient, do the negative reciprocal thingy, and I can find the gradient of DC. I can use the coordinate of C. I can find the equation of DC or CD. These two line meets at D. That is the next part. That is simultaneous equation. Show that triangle ACD is isosceles. That is about distances. So now let's start working. There is B, there is C. You find the gradient of BC. That's the same thing as gradient of AD. So use the gradient of AD, and that is this one. Use the gradient of AD, that is 3/5. Use the coordinate of A, you find the equation of AD. Similarly, the blue one, that is this thing, find gradient of AC, do the negative reciprocal thing, use the coordinates of C, that is the equation of CD. These two lines, they meet at D. So there is CD, there is AD, they meet at D, solve simultaneously. So now for this, I have to expand the equation. So the blue equation CD, that is this one, that's the blue one, that is the blue equation. This one is the red equation. And then what have I done? I have made Y the subject and I inserted it over here. So that's where the insertion takes place. You find the value of X, which is 8. And the corresponding value of Y is 10. Therefore, the coordinate of D is 8, 10. Is that what they're asking? Yes. Show that the triangle is isosceles. That is over here. So which triangle is isosceles? ACD. So let me write over here, triangle ACD. I have to prove that it is an isosceles triangle. That means two sides are equal in length, distance-wise. So let me work with A and C. Work in the third form, that is root 68 units. Work with C and D, that is root 68 units. I could have stopped my working over here, but deliberately I went ahead, found DA, that is root 36 units. Since two lengths are equal, therefore ACD is isosceles triangle, quite easily done. And that completes this particular paper of AS level, which is test number 1. and it is about coordinate geometry, straight line, and it is about circular measure. Take care, everyone.